can start our panel discussion. So our panelists are Dr. Bhavnani, you, and then Dr. Doswell and Sarah. So it will be great if you can open your video so that we can have Dr. Doswell is here.
Yes.
Okay.
Good afternoon.
Okay, thank you very much. So I think based on these 2 days workshop, I would like to have a panel discussion to have some questions and would like to know what will be the real challenges and questions that we have to address in our next phase of building this center for trustworthy AI in healthcare. So I will ask some of the questions. If you think you can like among all three of you, you can any of you can take that question, and it's not mandatory to have any of you which will be assigned for that question. So I will just ask one question and you can give your opinions on that. Okay. So my first question is, in your opinion and with your experience, can you provide your thoughts on the importance of trustworthy AI in healthcare? Whether you are working with some specific aspects of that, because trustworthy AI is a big term, but what are how can you provide how is it important in the healthcare domain?
Well, the implications of being wrong in the healthcare domain are huge, right? So the costs are very large. Now, if Amazon gives you the wrong recommendation of buying a shoe, the costs are pretty low. You just kind of ignore it or whatever. But in the healthcare domain, obviously, we know that the risk for being wrong is very high. It can impact patients. And so in my view, the first thing to build trustworthy AI is, of course, to make sure that the data and the algorithms are fair to begin with, and there are all kinds of methods that are being developed. But ultimately, it's really important for the users to understand what these methods are doing, right? So the whole black box discussion is extremely valid. But it's not really clear what that totally means. So I think more research needs to be done in terms of what do we really mean by a method being transparent, being interpretable, being explainable. These terms are being thrown around and people use them quite in different ways. And I think, we need to pay attention to those in our path towards trustworthy AI.
Yeah, I think in my experience, I agree with the sense that we need to kind of really define what we mean by trustworthy. So I think a lot of times in the AI community, words will be exchanged with each other as if they mean the same thing. So right. Some people say like explainability means trustworthy or interpretability means trustworthy. So I think defining what trustworthy means and then understanding whether that definition of trust is actually what we want is definitely important. There was a recent work that came out that looked at if you had like a trustworthy AI coach for users, the idea there was like the users believed the AI when it told them that it was good at its job. And then in the background, the AI was actually poor. It turns out that the user still believed the AI. So there was trustworthiness in that setting in the sense that the users almost internally agreed to or like internally convinced themselves that they should listen to the AI. But then when the AI was wrong, they over-relied on it. So I definitely think, I agree, yeah. Defining what we mean by trust, and then understanding like what is the end behavior that we want from users. We want them to rely on the AI when it's right, but recognize the AI when it's wrong.
Yep, and to elaborate on that, tools to help to validate what's trustworthiness. So artificial intelligence data sets, there are different types of learning models, like ChatGPT scours the entire web and the internet for data, wrong or right, and creates a model. So I think that verification and validation tools that can help to authenticate and ascertain what's correct and what is incorrect, I think that would make a difference. Otherwise, there was a seminal study, Institute of Medicine, and to err is human. I think that was 1999 and 1998, 98,000 deaths per year due to medical errors. As one of the panelists indicated, an error in a medical space can result in mortality, morbidity very easily. So really having some kind of external validator to ascertain that the data model or the artificial intelligence algorithm is correct or incorrect would definitely be meritorious.
Yes, I totally agree with Jayfus. Excellent point. So one thing that is a counterpoint is that AI, the way it is evolved, is a black box, and it hallucinates, as you know, the ChatGPT. And so for new topics, having a gold standard and validation is probably not possible. And so that's, I think, a very interesting challenge that that emerges. And one approach to address that is to have the human in the loop, so to speak, right? And so this whole approach called human-centered AI is an approach that has gained a lot of steam. Stanford has a whole program on human-centered AI. That's what we propose in our Aim Ahead grant. But it's still sort of an open question. What is the degree of the human? Who is this human in the loop? What kind of background would that human have? Can the human override decisions? Who has the final say? Right. So there are lots of very exciting new questions because in my view, at least in the near future, validating the AI, given that AI, even the developers of AI didn't expect AI to behave in the way it does, right? And so in the near future, it looks like it's going to continue to be this black box. And so we have to have guardrails, which is what I think you're implying, and the whole approach of human-centered AI, where the methods and the data are transparent, and the human or a group of humans are in the loop. I don't know. That's my current thinking.
Yeah, the other one is pedantically having real computer scientists to develop algorithms. So oftentimes, like my PhD is computer science, but oftentimes you have those that are not skilled in the area of computer science, developing algorithms and really doing it following standard software engineering methodologies. And consequently, there lies a problem of introducing data that may feed a model with incorrect information, right? Not understanding the pipeline of building an artificial intelligent model, like not doing the data acquisition correctly, pre-processing, the segmentation, the feature extraction, the feature engineering, the classification, and the understanding the nuances. Just like in software engineering, you have this thing called the strategy design pattern, having at the leaf, at the lower level, these different algorithms, be it a convolutional neural network, LSTM, recurrent neural network. They have different flavors of transformer and auto-instantiating it based on the parameters that are coming in, and then understanding the difference between a feature and a parameter and a label. So, those different types of those concepts and having the intellectual acumen to really develop, then it does not become a black box. as Marvin Minsky was both a cognitive scientist and a computer scientist.
Yes. While the discussion about trustworthiness, etc., is a worthy one where the focus is on the data and the algorithms, there's another dimension which is really the education of the user, right? To understand what these models are doing. And a lot of people who use, for example, ChatGPT, they just think it's like a glorified Google, right? So they're using it, but they don't really understand what's going on in the middle, right? Now, in all honesty, even the developers don't completely understand what's going on in their models, which is scary, right? But that's the reality that we are in. And I really think that it's not only making sure the algorithms and the data are unbiased and validated, etc., but also how are we as human beings entering into this new age where AI is getting so powerful and still a black box, right? So there are these other dimensions.
Yeah, wonderful thoughts. We got another question from the audience, and it's a really good question, I think, from Ernest Taku. Can AI and machine learning help reduce healthcare disparities? And what are the challenges in ensuring these technologies benefit all segments of the population equally?
Yeah, so in 2002, when I started my company, Juxtopia, it's a biomedical and IT company when I started. But interesting enough, we couldn't even use as computer scientists the word artificial intelligence without being taken. I mean, and not being we wouldn't have been taken seriously. This is so interesting that years forward is a very hot topic when artificial intelligence, in many respects, is not new. I mean, there's Alan Turing. The Turing test is the highest level of achievement for most computer scientists, is really a computer science challenge. I mean, an artificial intelligence challenge. But to answer your question, when we looked at like maternal morbidity and mortality rates of African American women that suffer from preeclampsia or postpartum hemorrhaging, and how can artificial intelligence or decision support systems, as they would say in the clinical community, looking at the clinical guidelines of ACOG, for obstetrics and gynecology, American College of Obstetrics and Gynecology, then how can you have an artificial intelligent near infrared spectroscopy looking at the fetal cerebral blood flow, oxygenated versus deoxygenated in real time, and make a decision like a clinician or nurse would make if looking at a rapid decel on a fetal heart rate monitor, and do it more accurately than a human being would, so that the complications or the interpretation of that data, depending on who it is as a clinician, and knowing that, and based on historical research, that non-minority clinicians would diagnose Black women a little differently so artificial intelligence may do that a lot better than human beings, because that implicit bias that are stored in our hippocampus regions in our brain would not be a factor in the diagnosis. And AI, if it's trained better than we are, then it would not make those same mistakes. So that's one aspect of how AI can address healthcare disparities.
Yes, in fact, that's a very good point, Jayfus, because in our research, when we spoke to many people, which I did not include in the talk, given the limited time, but there were lots of issues as to why people had not focused disparity research based on the actual needs. It's because the data was just not there, right? And now we have all of us that has like 110 social determinants of health and tons of participants, right? And so, but then if you gave these 110 SDOH variables to experts, they wouldn't know what to do with it. It's just too much data. It's high dimensional data now, right? And so that's where AI comes in. And therefore, when I had this discussion with the policy experts, they put all the pieces together. They said, now's the time to move away from race-based policies, not ignoring racism, but getting down to the actual needs that people have that cause the disparities, instead of partitioning people on race and income, which is, you know, I think pretty demeaning in my view, right? It's you're reducing people to variables that have no biological basis to begin with, you know? So why not go with the actual needs? And that struck this amazing note with the policy people. And they said, yes, we live in Texas. The Republicans would love that, you know, if you start with it, because we're flipping it, right? So we're basically saying we partition Americans based on their actual needs, because now we have the variables, and then we design the policy implications that are culturally sensitive based on after you have identified the needs, right? So yes, AI can definitely, I'm glad AI has passed the AI winter, which is what you were talking about, Jayfus. And now we're in the period where we're actually embracing that whole thing. But coming back to Sarah, right? Sarah, your initial point about defining what we mean by disparity, etc. They can be qualitative as well as quantitative approaches of doing that, right? So in your view, you know, do you have any thoughts about moving in that direction?
Yeah. Yeah. So I think there's been a lot of work on like, how do you define the outcomes for the patients you're trying to model AI models for? And then how do those different definitions actually affect who gets access to care? So for example, there was a study that showed that an AI model which was trying to predict if a patient got access to specific care, the model was trained to predict the healthcare needs of the patient. And so a proxy for healthcare needs is how much did that patient cost in like the X number of years before, you know, we collected the data. But it turned out that on average, Black patients just spent less money in the healthcare system compared to white patients. And so when the algorithm was trained based on their needs, which we used money as a proxy for, the model just systematically under prescribed the care to the Black patients.
I see.
So defining specifically what your outcome is or what you're trying to model is super important, because in one case, if let's say if you use hospital costs as a proxy, it's not necessarily the correct definition. And then if you use another measure that actually describes what the patient, like the actual patient need, then the model does much better. So then
great.
There's parity between Black and white patients.
Yeah, I mean that we have to get more precise, right? I mean, race and all of that, the simplistic few fact. It's not just demographic, but it's just you can't describe people with a few variables, right?
Mhm.
It's just much more complex than that. And AI can give us that power of defining people in a more complex way. Yeah, excellent point. Thanks, Sarah.
Yeah, I think
And the
another
program-
point
and-
to bring up, another point to bring up is oftentimes like one answer that people try to go to when modeling or training an AI model is just, okay, just remove race from the model. Just don't consider it. But what people don't realize is that if you have very high dimensional data, you probably have a lot of proxies for race or proxies for whatever you're trying to remove from the model, that the model is just going to latch onto. So I think, yeah, like really figuring out what do you need to define, what is the outcome that you want, what do you want to be like your measure of parity, and is that correct for, you know, it could be correct for one scenario, but not correct for another. So there's like a significant level of domain expertise that's needed for every single case. And then I think another thing is there's been a lot of work, obviously, on, you know, when we build AI models, we need to mitigate this problem of like, you know, bias and models performing poorly on certain subpopulations. One example I always use is pulse oximeters do poor or worse on Black patients compared to white patients. And so a lot of, you know, when you train AI models on data from pulse oximetry measurements, you have to do all these corrections, but maybe it's not the job of the AI researchers to correct it. It's the job of those who develop the pulse oximeters to fix the pulse oximeters. And then we don't have like this domino effect of, you know, then the bias ends up in the data, which is then in the model. If you just fix the source, it, you know, it fixes itself throughout the pipeline.
Again, the pushback is often you can't be perfect, right? And so you try your best, and then down the line, you make sure you have these, you know, protection measures, guardrails all through the pipeline. So
Yeah,
yes,
absolutely.
And in terms of pulse oximetry, there's a transformation that one can make after you understand what the differentiation is. Then you create an algorithm to understand it and make the corrective actions.
Yeah.
Because as you said, otherwise that would be an idealistic view.
Absolutely.
right. And then you introduce even more potential biases because you have an AI, you know, analyzing AI. So it could even compound the problem. But in any case, we have lots of interesting problems to deal with. And this discussion is really sort of enumerating them.
Yeah, wonderful discussion. I have just two more questions, I think, and then I think we will be done. My next question is about when we design a trustworthy AI system, it is having a lot of components, including explainability, and then going into the ethics and responsibility about fairness, and then security and privacy. So according to you, your opinion, what are some of the gaps and in these specific aspects? And when someone is doing research in this area, then which aspect is more critical or have to consider for like solving the problem rather than like going into all three of them?
Yeah, I could take on that question. Oftentimes, it's a software development lifecycle and having the team. So you have a data science team, you have a cybersecurity team, there's an AI ethics team. So I actually believe the Institute for Electronics and Electrical Engineers has a standard for ethical AI. Morgan State University in Baltimore has a funded type of program to validate AI algorithms based on an ethical AI policy. And then you have people who are trained in policy. So having a multidisciplinary team that's really intentional and not skipping steps, I call that lazy software engineering, then can really create this robust, interoperable, reusable, extensible software system that's grounded in true software engineering or computer science, from which artificial intelligence software derives. So it's team, methodology, and discipline.
And to add to that point is it's really important that computer scientists, data scientists, informaticians, whatever you call them, call us, we include social scientists in our process, right? Because the social scientists, they really understand how to get the qualitative data, how to analyze the qualitative data. We are trained in the quantitative disciplines, but it's absolutely crucial that the ethicists and the qualitative researchers be involved in this research because they can identify things that cannot be counted. That's the whole essence of qualitative research.
Yeah, and I think something I like to refer to often is just because something can be done doesn't mean it should be done. And so often computer scientists, when we see a lot of data, we get very excited and we're like, what can we build with this? But we're not trained necessarily to think about the long term. And so just because we can build something doesn't mean we should build what we're excited about. And having lots of different opinions and lots of backgrounds on the team can expose some of that thinking and say, hey, you know, maybe you shouldn't build that software, or it shouldn't function in this way or that way. So
That's
yeah.
an excellent point. And that's one thing that I learned dealing with the policy experts, right? Because when the debate occurs in the conference rooms of policy design, right? It's all about intended consequences and potential unintended consequences, right? Now, of course, we cannot predict the very nature of unintended consequences is that it's complex and you cannot really, you know, if it's obvious, obviously people would know that. But it requires a certain degree of brainstorming to think about the potential unintended consequences of the algorithms that we're developing, and this whole notion of socially conscious you know, methods as well as the policies around them require that that awareness that, you know, just because it's cool doesn't mean it may not harm people in the long term. So excellent point.
And then on the flip side, they're the adversarial experts, those who have the intellectual acumen to build very sophisticated artificial intelligence algorithms, to develop teams, but who intend to weaponize this wonderful tool. And that lies the problem in social psychology and sociology, that you know, groups of us, you know, our expertise have to contend with, and then really smoke out fast before that becomes a significant problem.
Yes, the most important point is be prepared, because it's probably already happening.
Thank you very much for the wonderful thoughts. My next question is about what are some of the critical challenges faced by AI developers or the computer or data scientists and clinicians on the other end to trust on AI systems in healthcare? Like you might have projects in collaboration with the clinicians. So what is the basic challenge that they are facing that side?
Yeah, we have a challenge right now with developing a human activity recognition system to train student nurses autonomously without a human nurse instructor teaching the nurse outside of a clinical environment on different psychomotor activities. The challenge is fundamentals, pure computer science stuff. So how do you segment human psychomotor task? Do you do windowing techniques or do something else that's very innovative? Also, there's feature extraction. So we're talking about input into a learning model. Oftentimes that becomes subjective, and hopefully there's a tool that identifies different features to go into the model. And then I guess what people consider the black box, or the combinatorial, you know, permutation of parameters that are created, and what that looks like. So it can be difficult to get your hands on 1 trillion parameters in a large model, for example. That becomes a challenge. But everything is pretty much set theory. There's no infinite state. It can be controlled, but the pipeline of how things are done, keeping and managing these different variables can be convoluted. And then really understanding the sequence of actions and how it's done. And, you know, I get down to the fundamentals of don't skip the steps, have a foundational understanding of how the processes are completed, and really understand how to develop the software algorithms based on true and de facto standards and standard software engineering techniques, then those challenges are ameliorated significantly.
So one of the most effective skills that I've seen that works in the communication between AI analysts like us and clinicians is to develop the skill of what we call method intuition. Can you take your method and explain it accurately, but without jargon, right? Can you build that intuition in your domain experts? Because otherwise, you know, these physicians have like 15 minutes, literally. They come into my lab and I show them the visualization. I've literally 15 minutes, because if I lose their attention in those 15 minutes, they're looking at their cell phones and they're going to the ER or whatever, right? So they're extremely distracted. How do you capture the attention of clinicians in a very short amount of time? That's where the visualizations are very powerful. We show them the picture on the screen. We explain in few words what it means, and they're off to the races. If they ask questions, then we have very simple English examples of how is this cluster being defined? How is this significance? But I teach that in my class. You know, I teach a class on big data visual analytics. And one of the skills that we teach in the class is how do you communicate complex information to people who are not experts? This is such an important skill, which a lot of people trained in the quantitative sciences don't have, because we are ourselves talking to our peers, right? Because we want to get our papers and our grants to be approved, right? And so we want to impress them with our formulas and whatnot, but that does not work when you're working in a team. So method intuition, the skill of explaining, and journalists do it fantastically well, right? So journalists can take, like on New York Times, they can take very complex topics and explain it in a very simple, it's not dumbing down, right? It's not dumbing down the science, but it's explaining the key aspects of it. And that's what we call method intuition.
Yeah, I would definitely second that. I think having the ability to, especially, so I come from the background of, like, I was a new PhD student and I had never talked to a clinician before. I mean, other than in the doctor's office, but I'd never talked to them about anything computational. And having to learn how to communicate what we were working on not only helped the clinician understand what we were doing, but it also helped me understand what we were doing, and contextualize it in terms of, like, learning. I not only had to learn how to communicate in plain language, the computational stuff, but I had to learn about the actual clinical setting we were working in. I had to connect what we were doing to the actual clinical setting. And then that in turn allowed me to think much more about, like, what are the actual implications of what we're working on. So I definitely agree. I think another very big challenge right now is we've done a lot of, like, we figured out how to build the models. We are really struggling with testing at, like, large scales, right? We can get it, you know, running in our hospital, maybe one or two other hospitals, and then it just comes to a screeching halt because not everyone has labeled data and not everyone has the same, you know, input features as us, and not everyone has the infrastructure or the time or the money to put into this. So I think a big barrier to adoption of AI in healthcare is going to be, how do we test these algorithms at a large scale? Or at least, how do we train individual models for the same condition across institutions and then still compare them and see how do we do in one hospital setting versus another?
Yeah, I think that's where, that's exactly the hurdle that we had faced in our project, and which hopefully will be addressed by CMS, right? So doing it as individual researchers is very hard. But if you go up to the policy level, right, and you're dealing with CMS, they mandate it, right? Here's the data, use this method, right? And so that's a whole different strategy that we had not known before. And talking to the policy experts just completely opened up my mind, you know, and communicating our methods to the policy experts was absolutely crucial, because then you could see, you know, all the gears moving really rapidly, and they got really excited. So yeah, they have actually made this whole project theirs. They call it our policy. And I was so happy to hear that, because I clearly cannot do this alone, right? If this has to go to Congress, my God, right? This is like beyond my expectations and beyond my comfort zone. And so they are taking it on. They will be calling the legislators and, you know, pushing it through. And it's, you know, many years ahead, but at some point we have to start. And it all began with me communicating clearly, not just to the clinicians, but to these policymakers.
Yeah, running a biomedical company, we have to talk to physicians across different specialties. But I used to work at National Cancer Institute on this project, old school, called it was a cancer ontology for nanoinformatics. And there was a defined set of data standards, and they were using HL7v2 version 2 for data interoperability. It was very effective to have the data oncology, the data interoperability among systems, so the systems communicate with one another, and I can see how that can be very effective for artificial intelligence data standards, and how the input to a model is defined by the other institutions, Sarah, that would be utilizing the other models, and therefore you decrease the variability. There's a consistency, and then there is a greater adoption of these different methodologies and models.
Wonderful discussion. Just the final question for today's panel. What are some of the recommendations that you can give for the prospective students or data scientists doing research in general in the AI field or in AI ethics?
Learn to communicate, just like we discussed. That's really, really important. Know your method. Don't just download these libraries. We have all these people who call themselves data scientists, right? They download these libraries and they push some data through without talking to clinicians, right? That's an absolute no-no in the biomedical field. So beware of these data scientists who are just doing that, right? They need to understand the connection, as Sarah was talking about, you know, communicate with the biomedical experts, the clinicians, each step of the way, right from selecting the features all the way down to testing or determining bias in the data and the algorithms. There has to be this close communication with the domain experts. And that close communication has to be based on this ability to communicate, to build. So we talk about trustworthy AI, but there has to be a trusting relationship with the biomedical experts, right? So you feel like a team, you have a safe zone, right? So you kind of convey to the biomedical experts honestly what your method can and cannot do. What is the incorrect interpretation of the method? But as Sarah was saying, you've got to understand very deeply what the method is doing, and no method is perfect. No data is going to be perfect, right? So make that transparent, build that trusting relationship. And to me, that's a very important dimension that often is sort of, you know, comes out when you're mentoring the student in the PhD program, but I think it should be institutionalized in the very courses that we teach.
Yeah,
Yep.
I completely agree. I think for like new, especially graduate students, you know, in undergrad, everything that we work on is very clean. They give you the data, it's very nice and like tied with a bow, and it works perfectly out of the box. Healthcare data is extremely messy. So looking, like physically looking at your data, like print out your data on your screen and read it and understand it and make connections between different data types is really important, because you'd be surprised what you'd find when you automatically extract stuff from the electronic health record and then it doesn't look like what you expected to pull.
Yeah.
So I'd say getting to know your data very well, and then having a lot of patience. So the AI healthcare timeline or turnaround time is much slower compared to other fields, because we're working with like real human data and you have to, again, communicate to non-experts of AI. So projects don't really wrap up in 6 months to a year. They take a long time and a lot of patience, and you just have to be patient with it.
Yeah, I would say get an apprenticeship, understand the institutional review board process that forces the ethics, and understanding the your programming language. Pick one, Java, Python. I'm a Java head. It was hard for me to adopt Python, but I had to. True computer scientists learn as many languages that they can because syntactically they're different, but semantically they're the same. So my advice is go back to the fundamentals. You know, be hardcore in your knowledge acquisition of the skills, the fundamental skills like computer programming, software engineering, artificial intelligence. Again, is not new. If you want to pick up something to understand how we build neural nets that is based on neuroscience, and hence that's why I double majored at Oberlin in cognitive neuropsychology and computer science. So both the behavioral science and the computer science, do something different so you understand both worlds. And the apprenticeships will help provide you with the experience to deal with the messy data and the non-sterile environments that are like you know, in the real world, and that's very, very important. I have a lot of employees and a lot of apprentices, and they in the transition from classroom to real world, a lot of times is painful. So that's why the apprenticeships, I think, work out well.
Yeah, have a good relationship with your biostatistician. Very important in this field, right? Data science, you know, we just created this department that forces the data scientists and the biostatisticians together. But at many universities, they are like miles apart, right? And so it's crucial to understand probability theory in addition to your machine learning algorithms.
Thank you very much, all the panelists. It was really great to hear your wonderful thoughts and your expertise in these areas. This is the first time I have organized the workshop, so I was a little scared, but it had finally got at the end. So I'm really thankful to everyone who participated and joined in this workshop. I am thankful to all the co-PIs and the students, and all the speakers who have agreed to come and speak in this workshop. And finally, a special thanks to our background heroes, David and Anderson Matt from our school, who basically worked a lot to make this event successful. So
And
be in touch. Yeah.
And thanks to you, you've been awesome. You've put together a fantastic workshop, despite this being your first time, and I hope you have many more.
Sure, sure. We will have an in-person workshop by next year. So most probably you all will be invited again for sure. Yeah.
Thank you so much.
Thank
Okay.
you.
Thank you very
Bye-bye.
much
Thank
and
you.
have a great day. Yeah.
You too.
Thank you.
Bye-bye.